So, gravity isn't exactly the same everywhere on Earth. It actually varies a bit depending on where you are, your altitude, and even the local geology. These variations are pretty small, but with precise instruments, they're definitely measurable. Earth is what we call an oblate spheroid. It's just slightly flattened at the poles and kind of bulges out at the equator. At the equator, you're actually farther from Earth's center, so gravity is a bit weaker there. But at the poles, since you're closer, gravity's a little stronger. The Earth's spin or rotation creates a slight outward force at the equator, which makes gravity feel just a bit weaker there. This effect is strongest right at the equator and drops to zero at the poles. The higher up you go, the farther you are from Earth's center, which means gravity is weaker. So, you actually weigh just a little less on a mountain than you do at sea level. You know, local geology, like mountains, mineral deposits, or even underground cavities, can actually cause tiny changes in gravity. Gravity tends to be stronger over areas with dense rock, and a bit weaker over spots that are empty or have low-density regions. So, gravity is about 9.780 meters per second squared at the equator, but it's a bit higher, around 9.832 meters per second squared, at the poles. Here's an interesting fact. Canada's Hudson Bay region has weaker gravity. That's actually because, in the past, glaciers melted there and a lot of mass was removed. Earth's gravity isn't perfectly uniform. It changes just a little due to things like the planet's shape, its spin, altitude, and what's beneath the surface. Scientists, well, they use this information to study Earth's interior and to monitor things like groundwater or tectonic activity.